All right, I believe we are live. A little 2 minutes earlier than the start time, just to make sure we are ready to go at 4:30, and everyone can join us at the proper time and making sure the stream is actually going through. So it won't start just yet, but let's see who is. Let's just make sure things are working. I'm checking out the link we provide, and yeah, I see myself. I see myself. Never been happier to see myself. Sound like a vain person. Anyways, we'll go ahead and get started in a minute or two. Let's see who is joining us today for office hours. I see Tom is with us. Hello, Tom. Hope everything is going fine. I have not forgotten your suggestion of Git version control. Haven't forgot about that. I think it's a good topic for the later half of the course. I'll make sure I do talk about version control, Git and version control. All right, so Q3 is driving you mad otherwise. All right, it's driving you mad. Well, we're going to start working through the mini project today. So we may not get to Q3, but we'll definitely probably get Q3 towards the end of this week. I think this is the most difficult mini project. It's really going to test your mettle. I think the tech sometimes is a little confusing, but that's why we work on these things in office hours and try out our solutions, try out our approaches. So we will tackle that. Let's see who else is with us. And I see Subham is with us. Hello, Subham. A little quirk in our system where you have to refresh if you go to the feed and it hasn't started before you got to it. You have to refresh. It is annoying. It's annoying. So perhaps we should modify the instructions to let people know they should hit refresh. It shows the benefit of reading the question carefully. Yeah, I guess so. Although I think the questions are it's a little confusing. It's it's a little confusing, but it's supposed to drive you mad. All right, hello Desmond. Hello Desmond. Welcome to Office Hours. I see Lyndon is here. Hello Lyndon. I put on the agenda the PW mini project. Put that on the agenda. Do let me know if there's additional topics to throw on the agenda. We do want to make progress this week on the PW mini project, which I think is the hardest of the 5 mini projects we have. Why 5? We got the IN, which is the introduction, IP, VC, PW, and DW. So once you get through PW, DW will be a lot more straightforward because we recommend you work on Pandas, which is a great tool, which is a tool for data science and data analysis. So hopefully you get the whole point of PW is get a good appreciation of those tools like Pandas and NumPy, which do things automatically for you, do things a lot easier for you. Hope you'll get a better appreciation of those tools as we get to those assignments. All right. Of course, Google, as Tom says, is of certainty of great help. All right. Okay, so let me know if any topics to throw on the agenda besides the PW mini project. And I will start opening that up right now as we speak. See, Emmanuel is here. Hello, Emmanuel. All right, so let's go and get started with today's office hours. Let's start off with the the PW mini project. All right, so let's import the static grader so we can grade our answers. Let's import that. Let's see, am I having some internet issues on my end? Hopefully not. Let me hit run that cell. Hello, Peter. Welcome to office hours. Let's see. I think it's a little slow on my end. Hopefully that can fix itself. Let me just do kernel reconnect. All right, let's try that one more time. Let's run that cell. I see Alicia is here. Hello, Alicia. Welcome to office hours. I see Olu Wagsegun. Hello, Olu Wasegun. Welcome to office hours. Let's go in. Okay, so we're going to go ahead and download the data set. And the data exists on an S3 bucket. Amazon provides web services, AWS, and one of the things the services it provides are these things called S3 buckets, which allows us to store data and very easily download the contents of those buckets. And that's what we do there. We create in what we see here. This stands for Bash. Bash is a scripting language, a shell language. Basically, it's a way to communicate with your operating system. In this case, a Unix-like operating system. We are running Linux here. So this signifies that this cell here is a Bash command. We're running the Bash programming language right here, the Bash scripting language. And the way we create directories in Bash is we call mkdir. In fact, one of the things that I have in my agenda for future lectures is a run-through of working in the command line, working in a Unix environment, because you might get the chance to do that. So I want to get you a crash course on working the command line, working in Unix-like operating systems and Unix-like environment. So we will reserve that for future office hours, but I do plan to talk about that. So here we create a directory. mkdir stands for make directory, the command to create a empty directory, which we call pw-data. We call the wget command, which is down wget. You think of webget. Download that data from these buckets. So let's run this cell here, and that's going to download the data. So now we have the data on our machine. And let's go ahead and load up the data, which is what we do here. Let's import gzip. Import simple JSON, which is a package to read JSON. It's a little bit, I think it runs a little bit faster than what's provided in the Python standard library. And I see Tom is saying once you've downloaded the data, there is an error message if you're trying to on for later sessions. Let's see that. Yeah, and it's not, yeah, I guess it's an error, but these commands still run. It's just saying that it already exists. But if you do need to delete it, if you do need to delete that data, you can always go into here. If for some reason you've modified that, you will have to delete them manually before you re-download them. So that is correct. There is that message if you run this cell before. I see Peter is here. Hello, Peter. Hello, Fabi. Is this course related to any modules of the Masters of Science of Financial Engineering? I don't know. I don't work on that side of the company doing the Masters of Financial Engineering, so I don't really know. I don't know what that curriculum is to be able to say that this here matches with that curriculum. However, I can imagine that the stuff here is of no importance for that track. There's definitely overlap. I just don't know that overlap since I'm unfamiliar with that curriculum. All right, and here, since we have compressed files, we have to use the gzip function, which we do right here. We specify the path to the file. We want to read it. It's a binary mode as f, and json.load set equal to scripts. Same thing with practices. Now let's examine the data we have. We have data from, I believe, the NHS, the National Health System, I believe, or National Health Health Services, based in UK, right? Their health system out there in the UK. And we have a data set regarding the different prescriptions that were issued by the National Health Service, the NHS. Yep, thank you. Forgot the word. I was going to say system, but it's service. Thanks, Tom, for backing me up there. And we also have a other data set regarding the different practices in the National Health Services. So different doctors' offices, different clinics and facilities, what's their address, what is their specific unique code, what is their postal address, things like that. So we have a data set regarding prescription data, and we have a data set of the different practices. And in the prescription data, we have information, we have fields that we can link those two data sets together. This is very important that we discuss this. So we have here We have our scripts data set, so our prescriptions, and we have here our practice data set. And we have a way where we can connect the prescriptions, who issued a given prescription. We have this information to link what doctor or what practice filled out a given prescription. So we want to go ahead and do some data wrangling, data analysis with these two data sets, prescriptions and practices. One of the first things we want to do is let's explore our data. We have our data. Let's look at the type. Let's look at the type. So I say type of scripts, and I have as a list. My data is a list. So I can examine one of those, and what I have is a dictionary. So I have a list of dictionaries. You can think of each element in our list as a given prescription. Where we have things like how many items were prescribed, a BNF code, BNF stands for British National Formulary. It's basically a specific code for a given drug. So this code corresponds to some sort of drug that's on file. We have a practice code. So you can think of our practices have a given code, and this is a code for that practice, so whatever practice has that code. Here is the name of the drug, the full name of the drug. NIC, I believe, is the net ingredient cost, and here is the actual cost, container fees and discounts. So here's the net ingredient cost and the actual cost, and quantity believes the number of capsules, grams, whatever was in that prescription. So nonetheless, we look at this here, looked at one sample, we can look at several, which we do right here, up right below. Each element is a prescription, and each prescription is a dictionary that contains information like who issued the prescription, how many items, the BNF code, the name of the drug, actual cost, things like that. Let's look at practices. Let's look at a practice. So that's also a list. Let's examine one of those indices. And sure enough, we have a code, which is the practice code. We have the name of the place, the address, the borough, the village, and a postal code. So here we have a data set for the information about prescriptions and one data set about information of the practices. And they are connected via this code and this practice. Practice and code, those are the fields that match up. In other words, I can take this here and I can look through the practices to look for that same code, and that's the practice that issued that prescription. Let me know if there are any questions about understanding this data before we move on and talk about calculating summary statistics. Let me know if there are any questions about this data set and what we're working with here. All right. So do let me know if they come up, but let's talk about summary statistics. For Q1, we want to come up with a summary statistic, so things like the total, the average, the standard deviation, the quantiles, the median, which is a quantile, and do so for all the various fields we have in our prescription data. So in other words, for our let's say for scripts, we want to figure out the total of items, the standard deviation of items, the 25% quantile, the median, the 75% quantile, and so forth for all the different fields in our prescriptions data set. So let's go ahead and flesh that out. Let's go ahead and encapsulate that process as a function. I see that Tim Hans is with us. Tim Hans from Germany. Yeah, I remember you were from Germany, so I know very little German, but gute Nacht, I guess, because it's nighttime over there for you. Yeah, ich spreche nur eine Deutsch. That's all I can pretty much say. Anyways, let's go ahead and talk about something relevant. This question here, let's flesh out this question here. Okay, so in order, I'm going to go ahead and just erase this. We just use it as placeholder. So notice, we're going to give it a key, and it's going to take the data set and start doing the summary statistics for that given key. So in other words, if I use this, if I say describe and I say items, what this should return to me is a tuple of the total, average, standard deviation, and so forth for items for the provided key. Guten Abend. You're right. Good. I guess good evening, right? All right. In fact, if well, we talk about this later. But anyways, all right. So what we can do first is we want to find the total. So we can first take the length of scripts, right? This will tell us the number of elements, how many prescriptions we have. That's going to help us out finding things like the total and the average. So if I want to figure out the total, what I need to do is I need to iterate through my prescriptions, pull out the key for each of those dictionaries, and then sum up the result. So in other words, I can say for script in scripts, and I can pull out for a given key, for example, all the items. This here is going to return me a list of all the item values of my prescriptions. And once I have that, where I can sum across them all, sum, and this here will give me the total. And once I have the total, then I can proceed to calculate the average. So notice here I'm iterating through every prescription, every dictionary, pulling out the value for a given key, put them all in a list, and then sum them all up. In fact, we can kind of practice here and say script items. Let's say for script and scripts. All right, I'll just index, let's say 10 of them, and we sum them all up. That's what we're essentially doing here. Okay. And now that we have the total, then we can easily calculate the average. The average is simply the total over how many we have. I can say total over n. And we're a lot closer to get our answer. The next thing we got to calculate is the standard deviation. A little bit of formula here. The standard deviation is really much a measure of how much an array of values vary from the mean. Do they vary substantially, or do they vary not so much from the mean? Standard deviation, deviation there being key. How much does it deviate from the mean? So in order to calculate the standard deviation, we need to calculate the mean. So what we're going to do is the formula for standard deviation is we go through all the values, x of I, we subtract by the average of x of I. Notice this here is a deviation, how much it deviates from the mean. We square it. We sum them all up for all our observations. So if we have 10, we calculate the deviation from those 10, square them, sum them all up, and we divide by the number of observations. And this here is equal to what is called the variance. This is the formula for the variance. So once we calculate the variance, then to calculate the standard deviation is simply the square root of the variance. So the next step we do is our standard deviation is just the square root of our variance. So that's the equation we're going to use. let me know if there are any questions about this equation right here. Do let me know. My only real connection to Germany is my ancestry, or part of my ancestry. I forgot where in Germany, but our last name was, before they came over to the Western Hemisphere, their last name was Fuchs, which I believe is the German word for fox. That is my but that happened in the 1800s when they came over to the Western Hemisphere. Okay, some have as 1 over n minus 1 instead of n, and that is a good point. And this here is, to be pedantic, we'd have to divide by 1 over n. And the reason why is it depends on the nature of this x here. This won't change much of our answer, but if x is a mean of a sample, then we divide by n minus 1. If x is the mean of the entire population, then you divide by n. However, if n is rather big, the difference doesn't matter as much. But you are correct that if we subtract by the mean of a sample, if we don't have access to the entire population, we just have a sample, we divide by n minus 1. But if we have the entire, if we know the average of the entire mean, we divide by n. Okay. Do let me know if there's any follow-ups, but let's go ahead and start coding up this solution. Okay. So same thing. We have to iterate through all our prescriptions, access the value, subtract by the average, square it, sum them all up, divide by n, and take the square root. Let's break that down. That's sort of the workflow here. So I can say for script in scripts, it's going to iterate through all of my prescriptions, and we're going to pull out the value. Pull out the value for the given key that was provided in the function. But we had to subtract by the average that we calculated before. And if we look at the formula, once we calculate the deviation, we square it. Which is what we do right there. We square it. Now let's look at here, and then we sum them all up. That's what this here symbol is. Sum them all up, and then we divide by n, or n minus 1. It won't make too much of a difference. In fact, I'm going to be pedantic, divide by n minus 1, since we actually calculate this here is from a sample. Someone is saying, could you import statistics module? Would that be allowed in this question? Yes, as long as you use the Python standard library. As long as you use the Python standard library, you should be fine. So if you import statistics, that's perfectly fine, because I believe this is part of the Python standard library. But we're going to do it here via Scratch. So this here is our variance. And then once we have our variance, we can get our standard deviation, which is simply the square root of our variance. All right. Now that we've done that, let's go ahead and let me know if there's any questions before we proceed. We gotta do the other ones, but this is a good kind of halfway mark for this question. right, and that's one of the things, right, we work on these to show you alternative ways. You might have done it via list comprehension. Okay. All right. So now let's consider the 25, median, and the 75% quantile. So let's first discuss what these things are. Imagine you take an array of values. Think of test scores. And I were to align them, if I were to sort them from lowest to highest. The halfway mark, whatever answer falls halfway in the middle, that is our median, the halfway mark. I used a for loop to calculate the sums. Yeah, so keep in mind there is the sum built-in command function. So the median is right in the middle. The 25% quantile is halfway. I didn't draw out the scale, halfway between the lowest and the median. Here is the 25. And the 75% quantile is halfway between the median and the highest. And these values are, we want to return what is the value that fell in at this point here. What value is located right there, right there, right there. So in other words, we take our array of values, we stack them in such a way where the lowest is at the bottom and the highest is at top, and we create divisions. The median is whatever value fell right in the middle. You sort them out, whatever falls right in the middle. The 25% is right in the middle of the lower half, and the 75% quantile is whatever is the middle in the second half. So my question to you guys, for those who have worked on Q1, what strategy did you invoke? Not necessarily code, but what strategy did you invoke for this second half of Q1, the quantile, the median, and the 75% quantile? Let me know what strategy you did take before I code up what we're going to do here. But do let me know if you've worked on this. What was your strategy? I'm kind of curious to know what you approached, how you approached it. See, Tim Hans is saying we had to sort the first array. Yeah, so definitely sorting would take in place. So we could do that. Let's try that out. So I'm going to create a list called vals, which is a result of sorted for script and scripts and script key. So this returns to us the array of values that has been sorted. And now that it's been sorted, set up the sorted list. Yeah, and once it's sorted, what you can do is we have to index the 25, the median, and the 75. Yes, Tim, sort the list. Yeah, exactly. So the Q25 is vals, and since we know how many elements are in the array, I can say n divide 4. So remember, if I have, let's say, the length of scripts is that value n, then I can say, if I want the 25% quantile, well, it's the n divided by 4. And I use divide because this here is floor division. If I do this, I get a fraction, but I want floor division. So index that value. The median, well, that's in the middle. In other words, n/2. And then finally, the Q75, well, it's whatever. Here, what I can do is I can say, so it would be, I can do 3 times n /4. I can do that. Or one thing I can realize is when I index a list and I want to count from the end, I use a negative index. So here might be a good way where I can use a negative index. Since I want this one right here, I want to count from the end. Let's use a negative index. So I can say negative n/4. Yeah, we can also use the get method of a dictionary. Anyone else do it slightly different here, how I got the these values? Here I use floor division and I exploit the negative indexing, but I'm kind of curious to see if other ones who have attempted and solved this one, I'm curious to see if you took a similar approach or a different approach. Do let me know. I am curious. I can try it out here. This is keywords. I think I have a typo for script. I got a typo there. Yeah, got a couple of things I think I did. All right. So now let's try out our function. Let's give it items and return a tuple of the summary statistics for items. And we can go ahead and swap this out and try out NIC, the net cost, I believe what that stands for. And notice it's getting all our summary statistics for all the fields. So here, just run that, and now we have a list of all our summary statistics, and we are ready to go to submit to the grader. So let me know if any follow-ups about Q1 before we pivot and work on Q2. Do let me know. The floor is open for questions or comments or things you want to mention about Q1. Want to share your approach? Feel free to do so as well. All right, I see Poyraz is sharing their solution. Yeah, you got the sorted list. Yeah, exactly. And the quantile. Okay, yeah, third quantile. Okay, yeah, someone is asking about, can you go over the get key method? Yeah, I can definitely go over that. All right, see a couple people's solutions coming in. Yeah, I see someone also did 3 divided times n. Yeah, that works just as fine. Yeah, several ways to go about it. They're all just as valid. All right. And yep, it's drier than mine. Yeah, I think a little drier than mine. I mean, I think mine is drier. But nonetheless, let's go ahead and someone's asking about the get method. Yeah, the get method is if I have scripts, and notice if I index one of them, I have a dictionary. I can call get, and get is a, well, sorry, let me back up. I can index my dictionary. Let's say I get items, right? We use the square brackets to get some value in the dictionary. Or an alternative is using the get method of a dictionary. So 2 different ways to get values from a dictionary. We can use the brackets. Yes, Poyraz, you can ask a question about this office hours. Go for it. We can also use the get method as well. They are equivalent. The difference, however, is that when we use this bracket notation and we try to access a key that doesn't exist, for example, it's called items, not item, we get a key error. But with get, if the key doesn't exist, you return none. So it doesn't cause an error, it returns none. If you want a different default value, you can pass it when we call get. Let me just open up a new cell, just out of completeness. Scripts 0, get item, and let's say if it doesn't exist, I want to return something else that is not none, maybe something like doesn't exist. Then I pass it as my second argument, and it returns that default answer. So get pretty much does the same thing as how we index over here. It's just that there's additional functionality of not causing an error if the key doesn't exist. Okay, so the question is, I wonder what we will investigate. Fourth question. Do you mean, are you referring to Q4 of this mini project, how we're going to go about it? Is that your question, Poyraz? Do let me know. Okay, while you clarify your question, I'm going to move on to Q2. And for Q2, we want to find the most common item. The most common item for every BNF name. So in our prescriptions data set, we have all these prescriptions for different BNF names. So you don't understand the first part of the fourth question. Yes. And in fact, what I'll do, and since you've come to office hours, I will work on Q2 and then I can clarify a bit about Q4. I do plan to work through, perhaps the way our pace, maybe towards the end of this week or early next week, but I can spend some time for this office hours to clarify your points about Q4. So yes, I will clarify Q4. I can schedule that for today's office hours. So thank you for bringing that up. All right, and thank you for clarifying your question as well. I appreciate that. So what we want to do is we want to go through all our prescriptions and create different groups. We want to create a group based upon each BNF name. There are different BNF names out there, the prescription names, and we want to group all the prescriptions that share the same BNF name. So this might be, I don't know, Tylenol. These are all the prescriptions for, I don't know, Advil. I don't know if these things are actually BNF names, but you get the point. Let's group our prescriptions by the value of their BNF name. So in this effort, let's go ahead and figure out how many distinct BNF names we have. And since we want to find out how many distinct or unique values there are, think of set, the data structure set. So we go for script, and scripts doing set comprehension right here, and we can index our BNF name, and this here returns a set of the BNF names. And sets only keeps track of every unique item, and we can calculate the length, and let's assert that it is, we pass the assert. Let's just try it out right there. You can just say length of BNF names. So yeah, a good example of using set here. All right, so what we're going to go ahead and do next is we are going to create a dictionary. We're going to create a dictionary where the keys are BNF name, and where the values are all is a list of prescriptions with the same BNF name. So for example, maybe I have a BNF name that's called Tylenol. I don't know if that's really the case, but just for example, we want to map that to a list of all the prescriptions, all the dictionaries that have a BNF name of Tylenol. So all these here have a BNF for Tylenol. And then we create another entry in our dictionary, for example, perhaps the word Advil, and that's going to map to a list of all the dictionaries, all the prescriptions whose BNF name is Advil. And the reason why we're doing this grouping is because we can go ahead and later on iterate through this list and calculate something like the sum, or figure out the length. So that's our approach here. Once we figured out all the unique BNF names, we're going to create a dictionary that maps the BNF name to a list. And we start inserting this list depending on its value BNF name. So now we have Tylenol and a list of all the prescriptions for Tylenol. Advil and a list of all the prescriptions for Advil. That's our approach here. So this is what we have it set up here. Notice what this does here. This here creates a dictionary where the keys are BNF names and the values are empty lists. They're ready there to be inserted. And we go through every prescription, and what we want to do is we say, okay, prescription, what is your BNF name? We'll call this BNF name. And this here is a dictionary for that. Oh, sorry, this here is the BNF name for that prescription, for one prescription. And then we're going to update the value of our dictionary. We say groups, BNF name, right, here is the list that we have. It's empty, or at least it can be empty, and we append the prescription script. So in other words, we iterate through every prescription, we look what its BNF name is, then we get the list of all the prescriptions so far that we've encountered for that BNF name, and we append to it the new prescription. So after we run this, let's take a look at what we have. If I say groups, and I say, let me just look at one BNF name that I have. One BNF names, let's see. That one right there. Here is a list of all the prescriptions that had this BNF name. Or I can prove it to myself. I can say for script in groups, and then I can say I don't know, true if script BNF name equals this Nexium, right, else false, I'll just kind of prove it to myself. Looks like they're all true. Yeah, they're all true. In fact, I can use the all function. The all function returns true if all the elements of an interval are true. So that seems to have worked out. So now we have this groups dictionary, and we created all the groups based on prescription. All right, let me know if there are any questions right now of what we've done. I set BNF names up as a list rather than a set. Is there any significance to that? This right here, the answer is you save yourself, because what ends up happening here is it's going to be, your process is going to be a little slower, by the way, if this had been a list. But what's going to happen is if you've already created the key value pair and you come across the same BNF name, since you're always initializing it to an empty list, there's no problem to what you have done. However, it's redundant. There's going to be some redundant calls, redundant runs, because you're going to iterate through the same BNF name. You set equal to an empty list either way, but you're iterating more than what you should. So it's not going to affect your answer, but it's going to make your code not as efficient. How much not efficient? Well, perhaps. Well, let's figure that out. Right, there's 5,000 BNF names, and we have 40,000 prescriptions. So if I do my math, 80 times slower for this construction right here. All right, let me know if there's any follow-ups before we progress on Q2. All right, so after read instructions below, I wrote this code. All right, let me take a look at that. Yeah, that's, yeah, you can kind of condense this into one line. I decided to do it in 2 lines. But you want to do BNF name. Let me see. Is this, Poyras, is this for your Q4? Just to let me know. I do plan to still talk about it today in office hours. Okay, now let's go ahead and finish this up. So now we've constructed our groups. We should sum the items for each of the groups. So in other words, for each BNF name, we will calculate the total of items, so that for each BNF name we know the total, and then what we want to return is the max. We want to return the BNF name that had the greatest amount of items and the total. So in other words, for each BNF name, we're going to find the total of items, sum up the items for all the prescriptions for each BNF name, and then we give the grader whatever, we give it the grader 2 pieces of information, the BNF name that had the most number of items and the most number of items. I see. You just appended not the entire dictionary, but the items. Yeah, that could have worked out. Yeah, because we just really care about the items. Yeah, that could have worked out as well. Poyras. That's since you're only giving it what we need for this question, so that would have worked out as well. You are correct. And maybe that'd be better because you just have your answer isn't as extensive. In other words, sorry, your data structure result isn't as big. It only has the relevant information, which is the items. Yeah. And that works out. That's also a good solution. And so what we do is now we have the groups, and we want to iterate through the BNF name and all the prescriptions. So I'm going to say BNF name scripts in groups.items. Remember that groups.items is going to iterate through over all key value pairs. So this is the key, and this is our list of prescriptions. And I name it as an underscore to have a different name than the scripts, which is our list of dictionaries for all the ones ungrouped. And now I can say, okay, well, I can calculate the total. I can say for script in scripts. And since I appended the entire dictionary, not just the items, I have to index here items. Then sum them all up, and I call this total. And then I can say items by BNF name, which is a data structure I haven't created, so I'll create it right here. Items by BNF name. And I append a tuple of the BNF name and the total. Got a syntax error. Probably forgot about equal sign, right? So in other words, I go through the BNF name and the list of prescriptions, iterate through that list of prescriptions to calculate the sum of items, then I append to this list the BNF name and the total. So if I look at items by BNF name, then I have the total items for each of my BNF names, as described by my, in my opinion, good name for this variable. So we're not quite out of the woods just yet, but do let me know if there are any questions, any follow-ups. Okay. And now that we have this list, well, we've got to figure out which element here had the greatest total. So I'm going to go ahead and pause right now. We will get to this, but I'm going to shift gears. And let's talk about a little bit about Q4, since someone did bring it up, and I thought maybe it might be worth talking about a little bit about Q4. And Poyras, if there is something specific about Q4 you are stuck in that you not sure what we're asking for, do let me know, but I do want to talk about the overall approach for Q4 or what it's asking for us. So Q4, let me just jump to Q4. Hope you guys don't mind as we pause Q2, and we can always talk about Q4 later on down the road, but I do want to talk about it right now. Make sure I have time for office hours to talk about it. It's for Q4. We want to figure out for every postal code, what was the BNF name that was, let's see, the most commonly dispensed BNF name for each postal code. So most commonly dispensed. In other words, let's say postal code, let me just think of a valid postal code, B114BW. Let's say the most dispensed item was Tylenol. So this would be Tylenol. And the other piece of information we want is the ratio of how many Tylenol prescriptions over the number of prescriptions in that postal code. In other words, for each postal code, we need to find what was the BNF name that was dispensed the most. And we want to also have this ratio, the number of Tylenol prescriptions, since it was dispensed the most for that postal code, for example. I don't think it's Tylenol, but first drug that comes into my mind, divided by the total number of prescriptions in that postal code. So if Tylenol was prescribed, let's say, I don't know, 500 times amongst 1,000 prescriptions for that postal code, the ratio would be 0.5. And that is what we want to do for Q4. And then now we need to calculate the total items for each BNF name prescribed in each postal code. So what that tells me, what that means is that I need to group by postal code and BNF name. And actually, I think this works well with what I wanted to do with Q2. Because in Q2, so I got to group by two fields, postal code and BNF name. And if we go back to Q2, we have this challenge section where we can write out a function that will allow us to group our data set by more than one field. So let's go back to Q2 now. Let's work on this challenge here. And then I think we were going to better set ourselves up for all the other questions downstream. I will pause this, how to figure out which one to return. But let's focus on group by field, this challenge here. And this will help for Q4 when it comes down the road. So what I want to do is I want to create my groups. I want to have more than one field, group by more than one field, like BNF name and postal code. And the way I'm going to describe that is I'm going to use a tuple. Before, my key was a string, but now I have two fields, BNF name, for example, and postal code. Then I'm going to use a tuple as my keys in my dictionary. So my question, so why am I going to use a tuple? Why not a list? Why am I going to use a tuple for my dictionary? Tuples can be hashed. And if tuple things can be hashed, they can serve as keys of a dictionary. So then, what I need to do is I need to iterate through each data for D and data. Right? This is like going through every prescription in prescriptions. I've got to generate my key, the key I'm going to use. And the way I'm going to generate my key is I'm going to say for F in fields, fields here is the fields you want to group by, for example, B and F name and postal code. And I'm going to create a tuple. So this is a tuple of my fields. I'm going to call this key. So in other words, for a given data, I'm going to iterate through the different fields I want to group by and return a tuple of the values of all those n number of fields. So for example, if for this data it's a given postal code B11 and it's Tylenol, then I will create a tuple of B11 Tylenol. And now that I got my key, then I can say if key is in my groups, then that means I'm going to append that data. Else, then I create a new key value pair with that key, initialize my dictionary with that observation. So now with this function, I can group by more than one field. So group by field, for example, scripts, and I can say group by postcode and B and F name. I think it's called postal code. I forgot what it's called. I forgot what it's called. Because it's in practice. That's why it's in practice. That's why it's not there. So BNF name and I don't know, some other field like NIC. It's groups, then S. And that might crash my kernel, in fact. No, it didn't. It did not. So what you need to do, Poirus, is you need to join. So but now that you've joined them, then you can take this function and group by more than one field. So I think this will give you, hopefully this will help you out in Q4. So I was able to make the connection with Q4 and what was happening in Q2. We are out of time, guys. So we'll have to pick this up tomorrow with working on finishing up Q2 before we march on with the PW mini project. So that said, guys, take care, have a good rest of your day, and see you tomorrow or whenever you join.